Okay, everybody. If you haven't heard already, we're passing around the homeworks. They are due next week in class at the start of class. They also are online if you need to get a few more copies to pass along to your friends and family. We've also, does anybody else need this constrained optimization example checked out? Come and get it. Take it. Anybody else? Hands? I'm not bringing them to class again. I think they're on the website. Sorry. Okay. Any open questions from anybody? Like, oh, I forgot, I didn't get that. I know there's some things you didn't get. Notice that 1 through 6 is revisiting some stuff in the last lecture. But any other stuff that's maybe not on that list that you have a question about? Yeah. Yeah, so here's what's happening with the videos. Because of our amateur production quality, although we have very high qualified staff, they are not suitable for the Berkeley main channel. So they're getting pushed into the community Berkeley channel, which is good because then it'll still be the best production quality we can get. And that transition from one channel to the other should be happening in the next day or two. Okay. As soon as I figure this one out, I'll send you an email, and then the videos will be posted. Okay. The MP3s of the lectures, with the exception of last lecture, which of course the batteries ran out in the middle of. I mean, this is like every possible thing that can go wrong is going wrong. But that's because we're not professional. And so the MP3s are basically up to date, as far as I can tell. All right, so you can go for a jog and listen to me. When we get the videos up, they'll be there. The people that sent me auditions for the transcription, thank you very much. I've got 4 or 5 of them that I'm going to look at and compare, and then I'll email you back and say, let's make a deal. So that will be kind of cool because then we'll have words flowing along the video. So let me also go over, I sent you this email on the blog post, and I want to go over this again in detail and get any questions from you because there is some confusion. The first person has already thrown their post over the transom, so you guys will be coming in with this stuff in the next couple of weeks. So it should be about a topic you care about. That's because you'll be more interested to write it. Don't pick something that you hate. Okay, pick something that you're interested in. But it should, and it's okay if it's not natural resource or environmental economics. I know that I said before I want you to do that, but I want you to do something that you care about, but bring economic analysis to it. Okay? Yeah.
Does it have to be like we read the economic naturalist? It has to be sort of that style as a question.
Something similar, like, oh, I always wondered about this, and here's what I think.
Okay.
Or I was looking at my roommate cutting their nails, and this is what I think.
What if we, this is kind of a stupid question, but if there is an economic reason, but really you think it's just because somebody's doing it around?
Yeah, that's also useful. Remember I said I had that Venn diagram with markets and known markets? Sometimes people might put economics onto something that doesn't deserve economics, right? Or there's a more appropriate explanation.
Like somebody's just greasy, there's really no economics.
Well, okay, so then you get into crazy stuff. Because economists, like, they've analyzed marriage, they've analyzed divorce, they've analyzed strategic death around taxes. Are your kids rotten kids or good kids? Why is it economic to believe in God? You can bring economics to anything you want. Whether or not you're right or whether or not you can convince somebody is a different story. So I don't want you to say, well, people talk about the stock market with economics all the time, but that's completely wrong. Because really what matters are sunspots. I mean, if you wanted to do that, make sure you show that the economics is worse than your explanation. Right? Okay. And, but that's fine. I mean, you guys are all going to go out there and say something, so that's what this is all about. Not just learning, but also, remember that the new ideas come from people that don't know what the right idea is supposed to be. So, if you come up with some genius explanation, I'd be very happy to be the person that instigated that. On the posts on my blog, I often reach a bottom line, and that usually means that after rambling for a couple hundred words, I want to get to a conclusion that someone can take away as the lesson that I'm trying to convey in the post. So I want all of you to have bottom line, colon, one sentence that summarizes what you just said, or what you just concluded, your analysis, okay? And it's almost like a technicality, but make sure you have one. If you don't have one, I'll push it back to you. And that can be bad if you're at the deadline, right? Because you'll miss the deadline. So have the words bottom line with a colon, and hopefully a sentence that makes sense. If it doesn't make sense, I'm sure the 1,000 or so people that read the blog might point that out to you. As well as your peers, right? And anonymous commenting is welcome on my blog, so don't worry about revealing who you are if you want to critique something. 100 to 500 words, send it in plain text. I already got an attachment, just put it in the body of the post. It's better if you don't have all the carriage returns in there, because then I have to remove all the carriage returns.
Email it to you.
No, email it to me in the text of the email. So, dear David, post, bye. Yeah? And I'm going to link, every post I'm going to link it to your email address that you send it to me. So if someone wants to reply to you, they will go to that email address. So if you're worried about stalkers, then set up a famous Yahoo account.
Images?
What?
Images.
Images, yes. Either send me a URL for the image or send me the image as an attachment. They're due at 11:59 p.m. I'm not going to read or edit them. Your typos are going to go up live, okay? So pay attention to that. If it's a huge typo, then I might change it. You know, you get the wrong century or something like that. But I'll make sure I shame you in terms of fixing that, because every minute of my time spent on these posts is time that you didn't spend fixing it. So it's 0 points. So it's 0 points if you do not do 2, 3, and 6. You must have economic analysis. You must have a bottom line, and you must give it to me on time. Okay? Any other questions about the blog right now? I highly recommend that you write it up and then give it to a friend to read and see if they like it or see if they understand it. Okay. Let's get into the discussion of the lecture today. So, first topic, marginal rate of substitution versus economic rate of substitution versus elasticity. So elasticity, as you're well and truly tired of hearing, is the change in the quantity from a change in price adjusted for price and quantity. Okay? This shape is known as a constant elasticity curve. Okay? Because even though the slope at point A and the slope at point B, this term here, even though that slope is different, right? When you adjust for P and Q, is that right? Yeah. When you adjust for P and Q, that'll give you an elasticity that is constant at any point on this curve. Okay? That's elasticity. Now, before last lecture, I was getting confused back and forth between marginal rate of substitution. So let's go back to marginal rate of substitution. Beer and chips. And the definition of marginal rate of substitution is essentially the change in chips over the change in beer, right? And it's actually, let's do it this way. It looks like a similar shape, A and B, but the marginal rate of substitution is the change in utility from beer, given a change in beer, over the change in utility from chips, given a change in chips, right? Change in chips. Now, it's a negative number because in economics we think of it as a trade-off, right? You're going to give up some chips or give up some beer and get the opposite. You give up some chips to get some beer, so it's a negative thing. One goes up, the other one goes down. Now, at point A, notice that we're not adjusting for where you are. Okay? That's why the marginal rate of substitution, which is just the slope, just like it's just the slope over here, this portion is just the slope over here, this is just the slope here. So the marginal rate of substitution is going to change. Okay? And it makes a lot of sense. When we were saying at point A, you're willing to give up a lot of beer to get one more unit of chips. Okay? So that's the marginal rate of substitutions here is different than it is over here. Just because it's an intuitive idea. I'm not trying to torture you with the math. I'm just trying to clarify why I was looking at one thing versus another. Because although both of them refer to slopes, This one adjusts for where you are, and this one does not. Okay? That's the difference. Now, there's a useful thing, which is the economic rate of substitution. And that, in a sense, is just the trade-off between the two goods in terms of price. So if we, I'm trying to do this carefully so I don't screw it up 5th time in a row. So we have, let's say, the price of beer equal to 4, the price of chips is equal to 2. Our budget, just for the sake of convenience, is 8. Right? If the price of chips is 2, we can afford 4 bags of chips and no beer. Okay? So the slope, or if we spend all of our money on beer, we can afford 2 beers. So the slope is going to be the reverse, minus the price of chips and the price of beer, which is minus 1/2. Right? And then we get this really traditional math equation. Beer is equal to 2 minus 1/2 chips. Okay? That's just a line. But this is in a sense, it's called by some people, and it's just a simple idea, it's the economic rate of substitution. You're substituting between one and another economically in terms of just going from a bundle of 2, 0 down to 0, 4. Yeah.
Does it matter if we switch like PC over PV?
No, I mean, it's just a question of what's on what axis, right? I'm just going to surprise you. Did I get it backwards?
Isn't it PV over PV?
I wouldn't be surprised. Is that right? I don't care. Is that right? No. Okay,
You switched the...
Democracy of mathematics is a wonderful thing. We want to go with that? I try to get it right, but I screw up. I mean, I'm like, rise or run. I'm in 4th grade math. Yeah.
Why is it linear?
Why is it linear? I just said it was linear. In terms of this thing here? This is linear because it's just the ratio of prices. Right? The prices are not changing as you move around between this bundle. Right? That's the main reason it's linear. Yeah.
I have a question about the marginal rate of substitution. So if the goods are perfect substitutes, then is the marginal rate of substitution always 1?
No, it's the ratio is the same no matter where you are on the line. Right? So it's not always 1. 1 implies that it's 1 chips to 1 beer.
Oh, but it's always the same thing?
Same ratio, yeah, because it's linear.
Okay.
Now we have chips and beer, and this is actually an indifference curve. It's not a budget constraint.
So the same up there is actually an indifference curve.
This is an indifference curve.
And the marginal rate of substitution changes where I'm on the line. So the only case where it doesn't change is the perfect
On the perfect
substitution.
substitutes, yeah. Right. Now, that's actually a good point because it brings up 2 things. One of them is that optimization in economics is that we have the marginal rate of substitution equal to the economic rate of substitution. What's going to happen when they're equal? There's 2 things that matter in economics, when curves cross or curves touch. Are they going to cross or are they going to touch when they're equal? Touch, right? We're just going to combine this and that. And we're going to find that our budget constraint here is going to touch our indifference curve here. Okay? That's the optimal point. That's the best we can do. Okay? Let's look at not a counterpoint, but a different version of this. Say that this is our budget constraint and this is our indifference curve. Can we do better than this? Yes. We can go to this is utility 1. We can go over here to this is a style I can't draw lines very well, but this is utility 2. Utility 2 is greater than utility 1, so we are happier at point A than all of these other points that we could have achieved. Well, no, we're happier at point A. We're happiest at point A. Okay? We can consume anywhere on this bundle, on this line here. Sorry. We can consume anywhere on this line because that's our budget constraint. Okay? We can buy a whole bunch of chips and 0 beer, a whole bunch of beer and no chips. But our happiest point is where we are on the highest indifference curve, where we have the most utility. Okay? Does that make sense? So that's where and we have the slope is equal to the slope, right? So that's where we have the marginal rate of substitution is equal to economic rate of substitution, right? Or the ratios, the ratios of utilities. Can I just draw them? Can I just U prime, is it B on the top here? U prime B, U prime C is equal to, did I get that? PC over PC over PV. And they're both negative, so those negatives cancel out, right? So that's essentially what you're getting. When you're doing the calculus and the Lagrangian and stuff like that, that is what you're doing. You're actually setting these things equal to each other so that, as calculus goes, when I wrote on this handout here, I said the reason that we set the first order conditions to 0 is because in calculus, it's about curves, right? And we want to get to the highest point of utility, right? Let's say that this is actually, let's say it this way. This is just a way of looking at it. Between the trade-off between beer and chips, we can have, a whole bunch of chips and no beer, or a whole bunch of beer and no chips. So we can go back and forth. And we're going to end up, because of the way that I've specified preferences, that you want to have a little bit of each. You're going to end up at some optimal point, which is the balance between beer and chips. And that optimal point is where the first order conditions are set equal to 0. You set them equal to 0. Right? That's the calculus. So you set up the Lagrange, you take a derivative with respect to x, you take a derivative with respect to y, you set them both equal to 0 because you both want them to be optimal, and then you solve them with respect to the budget constraint in order to get the bundle that you're going to consume. I can say it, but you guys are going to be doing it, and you're going to understand it, right? It's really, the idea is that there's just trade-offs, okay? And they're trade-offs between these things in terms of utility. They have to be constrained by something, and prices tell you what. Now, this is where this matters. Say that I change the prices of beer and chips, and say that I reverse it, and I go from 2 and 4, 4 and 2 to 2 and 4. Okay, so now I'm here, like this. Now, can I consume this bundle A? No. Why can I not consume the bundle A? Somebody. It's outside of my budget constraint. I can consume anything in this area here. Now, it could be possible that I would be actually indifferent to this price change if I happen to be tangent here. Right? Or I might not be very happy. I might have to go to a lower indifference curve because this indifference curve actually isn't tangent. Right? So I might be happy or I might be indifferent depending on the shapes of my indifference curves. Okay? And let's pound on that a little bit more. Does everybody have the same indifference curves? Like, just, when you go out to lunch with somebody, does everybody order the same thing? It's like, oh yeah, I'll have that salad, and no extra sauce, but no pepper, and a beer, no the half. I mean, people are different, right? So we assume. Sorry?
So the indifference curve is your personal preference?
In a sense, the indifference curves come from your utility function your preferences for things.
Is that economic rate of substitution data like slope of your budget constraint?
Yes, it is. The slope of the budget constraint is the ratio of prices between the two. But so remember that when you have a set of prices, here is you guys, here is me, and here's Bill Gates, right? I don't have half the wealth of Bill Gates, but you say this is the income that you got, income that I got, and the income that Bill got, right? But we all face the same prices, so the slope is the same. The budget constraint goes in and out depending on your income. I think I'm more like this, actually. Okay, another question? Yeah.
So do your preferences, are they influenced by the price, or because with the, if the price changes, will the shape of your indifference curve change too?
We assume that they do not. Okay? This means that you do not believe in the power of bling. Right? Or advertising. This is the debate among, marketing. If you go to get an MBA or you go to a marketing school, they'll say, we can change people's preferences. right? Suddenly you need something that you never needed before because the Apple advertisement, someone's dancing, or Coca-Cola, people are happy, or whatever, right? It's true. So, but for this class, and actually for most of the time, it makes sense that preferences are basically fixed. Okay? So if you change the budget constraint because your income changes or the price ratio changes, leave the difference curves intact. So how do we write up this indifference curve problem scenario? It's like, let's say that this is my indifference curve, and that's someone else's indifference curve. Okay? This is just representing the idea that this person has a different set of preferences than my set of preferences. Okay? So indifference curves of different people will cross all the time. I'll get to this in the Edgeworth box thing in a minute. Okay? So, but your indifference curves are not supposed to cross, and that's actually an assumption. It's a mathematically convenient assumption that I'll get to in number 4, which is not too far away. Yeah. Well, let me get to that all at once. So but you have two people, and one person might have a budget constraint here, and they'll consume here. And another person might have a budget constraint over here. Oh, sorry, same prices. Same prices. They'll have a budget constraint here, and they will consume at a higher. How many lines can I draw in here? This is one line. This is U1A. Start again. Okay, so. Budget constraint, indifference curve, same person, indifference curve, and their tangent here. Okay? Another person, let's just make it easier. They have a different budget constraint, same prices, so it's going to be parallel, but it's shifting out, and they have different preferences. So this is their preference. Zam, Zam. Turns out that this person only drinks beer, right? With the bag of chips that was. Okay? So you'll see someone consuming bundle A and someone consuming bundle B, even though they're both sitting at Jupiter, right? Same prices, same choices on the menu, different preferences, and potentially different income constraint, right? In a sense, that's the way the world is. That's why you go to the market and there's 80 different types of yogurt. Because somebody else wants to buy that stuff. And if it doesn't, of course, that brand will go out of business. Okay? Is that helpful? In terms of these differences and clarifications? A whole bunch of, oh yeah, awesome. Any questions now? No? Okay. Let's go on to the whole preference. How preferences map to utility, map to demand, map to outcomes. And believe it or not, that's almost all I need to say, but I'll say a little bit more. So this is the way that it works. Preferences are how you feel about things, right? I like cats, I like beer, whatever. And almost by definition, we cannot observe them. I cannot observe your preferences, or your preferences, or your preferences, right? I can ask you a bunch of questions, and that will be, when you tell me your preferences, you say, oh, that's my preferences. I have stated preferences, right? That's the technical word, stated preferences. Now, if I say, do you like chips or beer more? You'll say, oh, I really love beer, and I have 3 beers for every bag of chips. And then I go over to Jupiter, and I watch you have 2 beers and 1 chips. I'm like, what the hell is going on? There's a difference between stated preferences and revealed preferences. So this is what you say, and this is what you do. Has anybody ever noticed an inconsistency between what people say and what they do? Okay? This is the conundrum. Now, so first of all, we don't even know which is which, because some people will say, oh, I really do believe this, and then they go and do that. And you say, oh, you did that wrong thing. And like, oh yeah, I should have done something different. But it turns out that the ketchup was on sale, so I bought the chips. right? So here's the problem. It's hard to know what someone's preferences are unless you take everything into context. The weather, if they had a fight in the morning, how much the price of ketchup is, okay? So preferences, one thing is that it might seem like they're changing or people being inconsistent, but you don't know what's going on in terms of all the other things that you're trying to hold constant. Remember that hold constant thing that we throw out there as an assumption. So, and I'm pointing this out because in economics we assume that preferences are well, I'm going to write it down. You can write it down, but like, don't worry, I'm not going to have a huge exam question on this. Just for your understanding. We assume that they are complete. Right? If you go into the supermarket, you can tell me exactly the order at which you would buy things at the given price schedule. Most people go in the supermarket, they're like, whatever, I just got to get cornflakes, right? Or, ooh, that's on sale. Or, ooh, look, that's in someone's basket. So there's a problem that we assume that they're complete, but most people really have no idea. So this is an assumption which is maybe a bit fragile. We also assume that they are transitive. That's an easy expression for math. If A is preferred to B, and B is preferred to C, what do we assume in terms of A and C? But what happens is often you'll do this, you'll say, oh yeah, what do you do this and this and this and this, and they'll go, okay, you prefer A to C? No, no. Right? So this is horrible. This is like called irrational if you have intransitive preferences. Unfortunately, a whole bunch of people do. We also assume that the preferences are continuous. That means that as we go from 2 to 3 to 4 to 4.5 to 5, that those preferences will remain intact. Right? Why do we assume they're continuous? Math person. We use calculus a lot in economics. What is calculus about? Change of what? Huh? At a certain point. Change, so at a certain point. So can you have like a utility function that goes like this? You've got no point in the middle here, right? Because calculus depends on curves, smooth curves, right? You can't have that. You can't have this, right? You can't take a derivative of that because you run into this straight line problem. Okay? So we assume they're continuous because it makes it easy to do the math. Right? Once again, you go out in the world and people are like, no, actually, it's like the whole six-pack versus case of beer phenomenon. Oh my God, I got to make a decision, right? Do I get a six-pack of import or do I get like a case of Keystone for half the price? So if it's not continuous, the math breaks down. I'm pointing this out to you because these assumptions are made all the time and they contradict reality. Okay? So if you're sitting there in class going, oh my God, I don't understand why this is contradicting reality, you're still sane. But this is how we talk about preferences in economics. Big assumptions or some small assumptions. Non-satiated, remember that one? Now, they actually say locally. So it's a question of, 3 ice creams versus 3.2 ice creams, not 3 ice creams versus 30 ice creams, okay? But still, you're assuming local non-satiation because that basically means that your utility is going to keep going like this. It's not going to hit a wall, right? Or that it's going to go whatever, like that. So locally non-satiated means you do always want more in where you are right now. And also we assume preferences are convex. Convex is this shape that I drew between beer and chips. I keep drawing. This is convex, right? This is concave. What does concave imply in terms of your trade-off between beer and chips? What are you going to do? If that's optimal, here's your budget constraint. You're going to consume one or the other, right? It's like either all beer or all chips, which is kind of, that actually is weird. We're not quite into that, okay? So that's why we go for this convexity, which is you kind of, people like having a combination thing. Just a combination of things. You know, think of going to the Chinese restaurant for 6 or 8 of your friends. Everybody orders something and shares it off, right? Yes, you could have a huge bowl of rice if you want to, but usually you want to have some rice and some eggplant and some chicken or whatever. And that's what convex preferences imply. This is a lot easier to understand, right, in terms of making sense, in terms of reality. This doesn't make so much sense. These other assumptions, completeness, transitivity, and continuity, and non-satiation are almost all based on the need to use calculus and math for describing preferences and taking derivatives. Okay. Now, from preferences, there's this amorphous thing called preferences out there, and we take all these assumptions for granted. And then we say, okay, I have a utility function. My utility is a function of beer and chips. A utility function is just a summary of all of your preferences in one mathematical shorthand. Now this is actually a utility function. You can't take a derivative of it, but you do know that that person gets utility from beer and chips. If you wanted to, you could say, I have a utility which is beer to the alpha, chips to 1 minus alpha. Okay, now I've got a functional form. I can take a derivative of it, right? Or I could say it's equal to beer plus chips, right? What's this one? What is this? What kind of preferences are these between these two goods? What does that mean? Ordinal? I'm not going to go with that. They're not complement. Linear? True. If I have 1 beer and 1 chips, or 2 beers and 0 chips, substitutes. They're perfect substitutes, okay? It's just an example. These ones here are, remember, this is what I was drawing the other day. That's these indifference curves here. This one is this one. And what's the third one that I was drawing? The Leontief things. For perfect, okay, and what does it look like? What's the math? The min of either of those, right? BC. The set, BC. Okay? So these are different functional forms that describe our preferences. If I put a 2 in front of B, do I like B more or less than chips? The other less. More, right? If I have 1 beer, I get 2 udels of happiness. If I have 1 chips, I get 1 udel of happiness, right? They're perfect substitutes. Am I going to consume all beer or all chips?
All beer.
Oh, with one caveat I forgot to add. What was the caveat? The price, right? The price matters. If the price of beer is equal to 2 price of chips, then we'll actually consume probably identical bundles. Okay? So let's relate these for a second. Remember that this is economic rate of substitution, marginal rate of substitution, whatever. This indifference curve. This is an optimal bundle, given those kinds of Cobb-Douglas preferences. What's the optimal bundle for linear? Here's my budget constraint. Here's my indifference curve. Whoops. Right? Where am I going to consume? At the intersection? Can I get to a higher indifference curve? Okay. So if I go to a higher indifference curve, where am I going to consume?
All beer.
All beer, all the time, right? Bang. Whoa, is that parallel? No. That's parallel. Draw again. I'm going to do it with 2 different shapes of chalk. So this is my budget constraint. Okay. Here's my indifference curve. I'm going to go to this indifference curve, right? Because I can do better. I can still consume this over here. Okie dokie. That's known as a corner solution, in the corner, right? Now, where am I going to consume with these perfect complements? Here's my budget constraint. Do I consume here? Huh?
It doesn't
No.
matter. You can consume either.
Does it matter?
They're the same on that whole line.
Right, so I'm actually different between this point and this point. Right? But can I get to a higher indifference curve? Yes? Something like this maybe? Right? I'll just consume until my money is exhausted. Okay? So what you're going to do is you're going to get to the highest possible utility, the highest indifference curve you can, subject to your budget constraint. Yeah.
Why would you be indifferent between the spot that's inside your budget constraint and
On this one you mean?
Yeah.
Because these are perfect complements. This is the left shoes, right shoes. Right? So if I have two left shoes and two right shoes, I'm just as happy as if I have two left shoes and four right shoes. Okay? You just might as well throw those away. They don't even help. Okay? So that's a trade-off between these things. Now, our utility function describes our preferences, and we can do that with pure math. We don't have to have number, because here's the thing that's really important. What are we measuring utility? We're measuring these utils, right? What the hell are utils? It doesn't matter. So all we assume is that more is better. The more happy you are, the better off you are. And literally, if you actually are like an emo goth and you like being in a bad mood, then more bad mood is better, right? So that's okay. We could actually encompass those preferences for feeling bad in a utility function. The worse I feel, the better I feel. Okay, good. We can do that in economics. Everything will fit in there. But we don't know what that is in terms of numbers. We just know that the utility U1, U2, U3, we just know that we are happier on, or we prefer to be on indifference curve 3 than we do on 2, than we do on 1. Okay? More is better. That's essentially where it comes from.
All these curves are called
They're all called indifference curves. Yeah. And the indifference refers to the indifference between the two goods that we're portraying. Right? The utility function in reality, the utility function for David is equal to function of, beer, wine, travel, blah, 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 blah. There's 6 million, as many things in here as possible, because we assume that I have complete preferences. I can specify not only how much I like something, but how much I like it relative to everything else in the world at any given time. Right? That all goes into this utility function. All of you have got similar utility functions. Okay? And in the chalkboard, we're just going to say, hey, let's just do a world of two goods. But usually what happens in order to escape the beer and chips analogy is we just go, okay, let's do beer and then all other goods that exist. Right? Okay, that's simple. We took care of that problem. Right? So we just narrow the world down to two goods called beer and everything else. Yeah.
But what about people who don't spend all their income? And I don't mean like, okay, they just put some savings, because savings is just another good. I mean people who, let's say, they hoard a bunch of money in their mattress and then they die and it's never found and it goes and it's burned. And it's just lost. Like,
Right.
There's no...
So that's one of those reality conflicting with economics problems. But I think on the one hand, if you put it in your mattress, you might actually think of that as a security blanket. You might not plan to die when you do die, right? But the biggest explanation is that you save money now to spend it later, right? Including later, there's a multiple generations model where you save money now to give it to your kids.
So the future somehow would be good too then. It's like,
Well, my consumption of you can give me 15 cappuccinos today, or you can give me 1 cappuccino a day over 15 days, and I'm a much happier person. Right? So that's where the future comes in. But there's also, remember that spending money isn't necessarily going to give you utility. You might not spend money, and just sit on a park bench and be happy with that. That's spending time. Right? So that can go in your utility function also.
so time, is then time part of the income constraint? Or is it the...
It could be. Because remember we have we're using this letter M for budget constraint, or income, right? Well, if this M depends on how much time you work, now we start to endogenize M. We're assuming right now M is just a fixed number.
So just money for now.
At the moment, yeah, just a pile of money. Question? You got a hand up?
Oh, well, does that conclude with the, like, people who put money on the managers today, they like money today is worth money?
If you think money today, this is was Popeye and Wimpy, right? I'll gladly give you 2 hamburgers tomorrow if you give me 1 today, because it never gets you tomorrow. So Wimpy's always happy, right? But if you are someone who prefers to consume today rather than consume tomorrow, are you going to have savings? No. In fact, you're going to have a heavy-duty balance on your credit card, right? Because you'll borrow from tomorrow in order to spend today, right? So this gets to, we're going to get to later on in the course into time preferences and discounting and stuff like that. But that's what's going on there. You have a question? Yeah.
If you have utility by having, or if you get utility by just having money, would your M need to have a variable on it?
I would, M we're just going to use purely as money. If you get utility from having money, then you would have something else in here, not M, called savings. And that's kind of like, you have a preference for savings because that's a form of security, or it's a form of benchmarking, so you can point to someone else and say, I have more money than you, something like that. This M functions as a way of constraining our consumption. So if you want to, you can call this, let's call this M1 for money that you're going to spend, and there's another thing called M2, which is money that you're going to save, and together they're equal to M. So functionally, what you're talking about, savings makes you happy, you want to put that in utility, right? But in terms of accounting, you have another thing called money that you're spending. Because you want to consume things, right? And consuming time, consuming savings, consuming walks in the park, that's all consumption under economics. They all go in your utility function. Okay? Questions over this side? Any hands? Any other hands? Okay, so from our preferences to utility, and then from utility we're going to get a demand. The demand for the good depends on what? Price. That's the answer, right? Depends on the price. That's why when we draw a demand function, the only things on it are price and quantity, right? Demand is a function of price, or quantity demanded. This is exactly the same thing, right? Or notice that quantities are over here. Inverse demand, P is equal to 1 minus Q, right? Another demand function. So when we talk about preferences, we're talking about bundles of goods, combinations, utility, how happy I am to have a various consumption good, a bicycle or a sunset. When it comes to demand, then we are going to include prices. We're going to include money. We're going to include the constraints of budget. That's why we talk about the marginal rate of substitution and the economic rate of substitution meeting. Chips and beer. And very similarly over here, it's not this line here, economic rate of substitution, is not the same as this line here. Okay, but it is bringing up a similar thing. Our preferences are on here. This is driven from utility, and economic is from prices. And here we have a demand function which relates how much we want given our preferences based on the price. Okay, so in a sense, this will go to this, right? Did you have a question? And then we're actually going to witness, in the market, we're going to witness this. Q star of an individual, right? How much does somebody consume? Well, I can see that. That's their stated preference, or revealed preference. They consume this many of whatever these are, quantity of beer. So I see that at a price of $3, they consume 2 beers. And that is being, if we go backwards, it's like, oh, because there's a price trade-off between beer and chips, or beer and all other goods. And that trade-off is the prices that that person faces. They have a difference curve determined by the preferences between beer and all their goods, which is expressed in the utility function, which is comes from wherever the hell preferences come from. You see how that comes backwards and forwards? How the system of relationships kind of go from preferences out to outcomes in the marketplace? Does anybody not see it? You're all so happy looking. Revelation! No? An example?
Even more clear.
Beer and chips? More clear than beer and chips? An example, I mean, you have your preferences for these items. They are related to each other in a utility function. Then you go on the market and you look at the prices that you see, and then you choose how much to consume. That's what's going on, right? Hopefully, it makes a lot of sense. But I mean, it's easy for economics to get so complicated that you're like, oh my God, I have no idea what's going on. That's why I want you to see this relationship from this linear relationship from one to the other. Yeah, better. Okay.
The quantity demanded, is that the quantity sold or the quantity wanted?
Wanted is infinite because of non-satiation.
No, but I mean,
Purchased, sold.
I mean, if, for example, at a given price. So let's say
The price is 3, I buy 2.
But let's say the price is 3, I want to buy 2, but actually because the government has put a price cap on it, there's a shortage, I can't buy 2. I can only buy 1 because...
So the price is not 3.
No, but the
The price is different.
But the price is 3 because the government said that the price was 3.
Well, the price of beer on the moon is 12, but I can't get to the moon to buy it, right? So we're talking about a transaction that you can complete at a price that you do face. So the price of 3, maybe the price of beer is 1 plus $2 of waiting around to get your beer, right? Or it's 3, but when you put that government price floor into account, it actually ends up being 5, and then you go from 2 to 1.
So is 1 the quantity demanded, or is
Given what you just said to me, yes.
Okay, so it's not the quantity that I really want at that price, it's the quantity that I can possibly get at that price.
Yeah, so this is the relationship between prices that you face, whether or not it's a cash price or a time price or any other price, and the quantity that you demand. That's the relationship. Okay? But if you're...
So even though the nominal price is 3, my actual price is 5, which is why I can only get 1.
Right. So these are real prices here, not the advertised price, right? Not the price that is happening in Malaysia, but that's the real price you face. Yeah. No, that's a good question, but this is meant to convey real prices, and so you're going to make a real choice based on a real price. Here's another way of looking at that. So look, that was just a demand function, right? Let's do your scenario here. There's my demand function, okay? Here's a supply in a free market or whatever, world regular market, quantity, price, and then the government says, we're going to put that's a supply curve, but we're going to put I'm just going to make it simple. I'm just going to say a tax. We're going to put a tax on here, right? So now the price is higher, and you consume less, just like that. Okay. So the supply curves are where the pricing action that you're talking about is going on. As a consumer, you just look at what's out there and you decide how much to consume.
I mean, a better example, for example, if there's a sale and they advertise, okay, you can get 5 hamburgers for 50 cents each. And everybody runs out and gets hamburgers. And actually I decide when I see the ad, okay, I want to buy 10 at that price. But then I get there and they just don't have 10 left. They only have 2 left. So then the quantity...
So this is your supply curve.
Okay.
It stops.
So it's the supply curves that...
Yeah. And our preferences are not changing. The preferences are intact. Yeah. You're going to do that on your homework. What's the difference between what do you add in order to get demand? What? Say it. What do you add? Prices, right? So how does utility get to demand? You add prices, and then you find out what your demand is given a set of prices. Okay? Okay. So when you do this Lagrangian stuff and you solve for x star, like your optimal, your demand schedule, then you're actually going to see how much you're going to demand given a price. This is definitely homework stuff. Yeah?
So the horizontal lines are the supply curve in the market.
In this particular example, that horizontal line is the supply curve. Right? So supply curves, they start low and they go high. Sometimes they're flat. Okay? That is not the world's only supply curve I just drew. Right? Yeah? Okay. Usually it's like this. Sometimes it's like that. That's okay. Other questions? All right, rolling right along. You don't even want to get to production today, I can see. All right, that's fine. We're trying to learn here, not to lecture. All right, but we're going to get to edgeworth thoughts, which is so fun. You guys didn't even have any of the fun last time. I really felt like I was robbing you. Okay, so how to optimize hints, right? Remember, you've got a utility function. This is directly applicable to your homework. Dot, dot, dot. Okay? Take good notes. You've got a utility function. You've got the price, and you've got the budget, right? If you've got perfect substitutes, my utility function between good x and y is going to look like what? Give me an example. What? All right, let's do x and y. Not b is equal to a or whatever. What's it going to look like? What's the math on this side of the equation going to look like? Yes, nice. X plus y. If it's perfect complements, what's it going to look like? Minimum of x, and y, right? And if they're in between, what are we going to call it? I'm just going to call this normal. It's going to look like what? Huh?
X alpha y 1 minus alpha.
Right. I'm just going to say x alpha y. Oh, is that what you just said? Okay. I'm going to say what you just said. So, look. Can you take a derivative of this? If you set up a Lagrangian, remember what you're going to do. You got your utility function. You have a Lagrangian is equal to utility minus the thing, price of x plus price of y minus m. Right? That's your Lagrangian. Can you take a look? Can you use the Lagrangian method to solve this? Yes? Because why? What are you going to do?
Take the natural log.
Not necessarily take the natural log. Your first step is actually, that's the hint, take the natural log. The derivative with respect to x, the derivative with respect to y, the derivative with respect to lambda, right? Come on, frat people, help me out here. All right? There are frats at Berkeley. Okay, so you take your derivative. So calculus works. Yay. What do I do with that one? Can I take a derivative of a minimum set?
No.
No. How would you solve that? Let's say that my preferences are the minimum 2x, y, price of x equals 3, price of y equals 5. And m is equal to 15. If I spend all my money on x, how many can I buy? These are my bundles here, right? 5, 0. Spend all my money on y? 0, 3. Right? So you can see that there's going to be some... This is an SAT question. Fill in the blank. Okay? Do you see that there's going to be a trade-off between these two? Okay, good. 4, 3, 2, 1. If I buy 4 of x, spend 12, can I buy a y? 3 of x, I spend 9, can I buy a y? Right? 2 of x, I spend 6. 1, I spend 3, and I can buy 2. Okay? My minimum of 2x and y, so this is 10, 0, 8, 0, 2x, 6, 1, 4, 1, 2, 2, 0, 3. Which bundle am I going to consume?
10, 0.
My utility from the bundle 10, 0 is the minimum of these two numbers. The minimum of 10 and 0 is
0.
0. Okay, can I beat 0?
Sure can.
Okay. What would I do?
2, 2.
I can beat zeros, right? Yeah, 2 and 2. Right? 2 and 2 is the answer, right?
So you have to have at least some of one thing? Is that what the minimum is saying?
It's whatever you consume the least of is what your utility is. So if you have 0 of it, then your utility is 0. So in some ways, yeah, you have to have at least some. It's a different argument in favor of you have to have at least some of something compared to this argument, right? So you can still have utility of 1 or 2. Question? Yeah.
Well, when you do 2, 2, are you using all of the 15?
No. That's often why we say subject to the constraint. In this case especially, px, x plus p. Where did I write this down? Y, oh. Y less than or equal to m. You can only spend what you have. You can spend less. But there's no additional utility from that left over. Hold on. Yeah.
So if you're going to graph that solid loader, would you not want to graph it?
Perfect exercise. So look at this though. What's your utility here?
0.
0. What's your utility here?
0.
What's your utility here?
1. 2, 0.
Okay, so how many indifference curves will be mapped by that set of outcomes?
3.
3, right? One indifference curve called 0, another one called 1, and the third one called 2. So yes, you can map that out.
Wait, why is it 1 is 6 and 1 and 4 and 1? Why is the utility 1?
The minimum of the two numbers. This is a very, it's a different way, it's a different kind of utility function. It might seem like it's just academic, whatever, but it is quite helpful when you want to think about, stuff besides left shoes and right shoes. But yeah, go ahead.
Are the 3 indifference curves just flat lines or vertical lines?
They look like L's.
Oh.
Remember? Okay. Other questions? Yeah.
What would you, I think the numbers,
These numbers?
yeah, like
What I can afford?
Well, like
This is what I can afford. This is my utility map. This is figuring out my utility. So this will be like, I'm going to call this a transformation. And this is actually utility. I'm going to shut that down. Good.
Okay.
Good? Good. Okay. Good? Good enough? Yeah, sorry.
Can we only use whole units, or can we use fractions for that as well? Because in that case, if you don't spend all your money, that's not what we said before, because you try to reach the corner, right? But right now we're still cutting the L shape.
Right.
So,
No, I'm going to just leave this discrete. Right? No fractions.
okay.
Right? Integers.
So we're forced to cut it.
I'm going to force you to use integers, because you can't buy a half a beer. Right? Or 3/4 or 0.62 of a pizza. Okay.
Thanks.
Any other questions about this? Yeah.
How did you get the values in solid?
Under these, I took the minimum. So what I did is I said, these are the quantities. This is my utility mapping, right? The minimum of 2x and y. It's not just x, y. So 2, 5 is 10. The minimum of those two, right? Okay, so that's my utility attribution to each of those goods. This is how physical, this is how I feel about it, and this my utility is the minimum of those two. The minimum of 10 and 0 is 0, right?
How'd you get Y again? Was that,
I just spend all my money on X. Price of X is 3, right? This is what you need to do in terms of doing this calculations, yeah.
Would you have to draw the indifference curves for this situation?
If it is helpful to you, you should draw the indifference curves. If you get the answer right, I don't care what you do. Show your work. Other questions? Okay. Now, Mr. Edgeworth. I just kind of threw that out there. I didn't realize how significant the Edgeworth box was, so I'm going to spend a little bit more time on it. It's written, came up, the guy that came up with it, obviously Edgeworth, he was an intuitive kind of economist who worked about 120 years ago. But what the Edgeworth box demonstrates is it demonstrates how this world works. Okay? Without having to worry about this world. So price doesn't necessarily matter. And I'll show you what that means. Okay, so let's set up this world. And I'm going to say we've got Mr. A, Mr. B. We've got two goods. We've got beer, we've got chips. The total quantity of beer in the world is 5. The total quantity of chips in the world is 10. Mr. A and Mr. B
That's not marginal revenue, it's Mr.
Whoa.
Okay.
No, this is Mr.
Okay.
It's not marginal revenue. Production is number 7. We're on number 6. Okay, indifference curves that I just showed you, do they have the same preferences or different preferences? Different preferences, good. Now, I'm going to start off each of these guys with a bundle. Let's see, Mr. A has 2 beers and 6 chips. And Mr. B has 3 beers and 4 chips. What I want here is I want someone, okay, so Mr. A, I'm going to try and actually make this match. Mr. A has 2 beers and 6 chips. What I'm trying to show on this indifference curves is that if you sit there and if you take away 1 beer from Mr. A, do you have to give him a lot or many or few chips compared to Mr. B? Many, right? That's that run here. So this is meant to be just 1, let's call that 3, call that 1, whatever, right? So Mr. A, relatively speaking, prefers chips to beer compared to Mr. B. That's just kind of something you can observe from the shape of the indifference curves. Now, what the Edgeworth box does is it combines the preferences of these 2 folks. And we have, this box is 5 units tall because it's a box of what? Beer. There's no beer in here. And here's chips. Now, now if I wanted to put Mr. A, this is the origin of A, I could draw indifference curves. Very similar. See that? just going to put those indifference curves in there. And Mr. B's indifference curves, I've got to put him up here. I've got to flip him upside down so that this axis is beer, which it was, and the other axis is chips. So I'm just going to do it kind of like I would upside down, like that. And just rotate it like that. This is a bionic rotation. Can you see how that happened? You did, right? Okay, now, here's the part that gets interesting. The distribution of goods in this world is as follows. Mr. A has got 2 beers and 6 chips. And 4, 3, 2, 1. Remember that this is increasing chips, and this is increasing beer, and likewise. Okay? Now, where does Mr. A start in terms of the endowment of goods that Mr. A has?
2, 6.
Or rather, even these axes, 6, 2. Right? 6 units on x-axis. 1, 2 chips. Mr. A, 6 chips. 1, 2, 3, 4, 5, 6 chips, and 1, 2 beers. Okay? That's where Mr. A begins. Where does Mr. B begin? Where's that going to be? Same place, right? They start off right here. Because all of the units are accounted for. We go up, we go down 3, and we go over 4, right? So this is basically the starting amount of, the starting distribution of wealth in the world. And let's just draw in a different curve through there. I'm going to call it IA, right? IP. Whoops, that's a little bit too steep. Do we see how those indifference curves are just extensions of the general pattern of indifference curves? Okay? Mr. B, ba, ba, and this one here. These are indifference curves for B, right? You everybody see that? The shape is basically the same. Okay, and A, likewise, going like this. Okay, so here's what we get. Here's our question. First of all, does Mr. A want more beer or chips? Yes or no?
Yes.
Yes. More is better. Does Mr. B want more beer or chips? Yes. Now, can both of these people get better off by trading with each other?
Yes.
There's no prices, remember. Can they trade? Where would their trades go to? In the eye. As in this eye, the eye of the needle?
Yes.
Otherwise, the technical word for this is the football, right? So in the football, we have a whole bunch of gains from trade possible. Because either of those people would be better off getting to an indifference curve that was in the football. Or the rugby ball. Or the fishing ball. Whatever. So either of them would be better off. If Mr. B, just for the sake of example, if Mr. B is on the same indifference curve here, and Mr. A gets to here, then A is better off and B is not worse off, right? So they would both be happy. But look, if we did that, then there's this even smaller, there's still a football here. It's smaller, but it's there, right? these guys end up in terms of their, where should they end up in terms of the mathematics of where they end up from trading with each other? They should touch. And what will happen when they touch? Or what way do they touch? A special way. What? There's no area. Okay. But what's the mathematics of where they touch? They're tangent to each other, right? Because in calculus, what's just happened? They're optimized and right? The marginal rate of substitution between Mr. A and Mr. B will be equal because they will be tangent. So just, let me just draw this little thing here. And so this is going to be bundle 0. This will be bundle 1. Okay? Bundle 1, God, does that even say anything? That's why I talk and write, because I can't write what I talk. Bundle 1, right? You go from bundle 0 to bundle 1. Both people are better off, and they can't trade anymore in terms of making each other better off or indifferent, right? The only thing to do now is to start hating each other and stealing from each other, right? But in a world of voluntary beneficial trade, you will get from bundle 1 to bundle 0, right? And it turns out, other way around, bundle 0 to bundle 1. Thanks for laughing at my mistakes. That helps me understand what's going wrong. Okay, so you'll get from bundle 0 to bundle 1, and that is that's the end of trading, right? You started here, you traded until you got there. You could end up, could you end up at another point besides this point inside the football? You could end up almost anywhere. There's actually we have no way of understanding where people will end up, okay? Psychologically, people tend to want to, I'll give you some of this, you give some of that. So you tend to want to get inside more, but you could theoretically, you could end up anywhere on the lines or in the middle there. Okay? It actually depends almost on the power positions of the people, and that's where we put it. But all you need to know is you'll end up somewhere in the middle. Now, at that tangency, the marginal rates of substitution are equal. There's no prices, but if you wanted to set a price, what would the price be? If you wanted to, if you're an outsider, you said, you know what? I think I can set a price now. What would you set the price at? Don't give me a number. What was the concept that you would use? Right? You would set a price, essentially, that is a straight line passing through that tangent point. Because that's what we deal with all the time when we're doing the market. There's my indifference curve. There's the price. There's the point of the optimal point. These guys are trading, and they arrive at an exchange rate, literally, between the two goods that is essentially the same thing as the exchange rate that we use with price. Okay? This price, remember I used that word endogenous? This is an endogenously determined price, just because of the trading going on. And if it turns out they end up at some different point in the bundle, then there'll be a different set of prices. But that's okay. Just all you should know is that where they end up exchanging is where they end up setting prices. Okay, any questions on that? All right, I'm going to get quickly into production and certainly not go through all this stuff. That's the end of our first go-around with the consumer theory. this is going to blow your mind. So in producer theory, we've been talking about utility being a function of the bundle of x and y that you consume. As an example for Cobb-Douglas, x to the alpha, y to the 1 minus alpha, right? Remember that important caveat. Alpha is in the set 0, 1. In producer theory, shocking, we use exactly the same format, terminology in mathematics. It usually works, just like it usually works in consumer theory. I'm sure I'll get to all the places where it doesn't work, right? But this, K is what? Capital. Woo! Marks, okay? Labor. So they're essentially production is a function of your capital and your labor, right? If you feel like it, go ahead. You know, let's call it capital and all other inputs. That's fine. Same game. It's the exact same thing. Right? Basically what it says is if you have no capital, can you produce anything? No. If you have no labor, can you produce anything? Right. So this is the same, it's the same analysis, it's the same method of, it's the same analogy, the same way of thinking, but we're just using it to produce other goods. Now let me ask you, do you see a parallel here? U, marginal utility, falling, output, marginal production, right? Utility increases at a decreasing rate. Marginal utility is falling. Output increases at a decreasing rate because marginal production is falling. Because of what's the expression? Louder?
Diminished returns.
Diminishing returns. So now, instead of diminishing returns to consumption, we're dealing with diminishing returns to inputs. Okay? One of the most important inputs, and I'll stop on this sentence, is the entrepreneur who runs the business. Okay? The reason that we don't have one company that does everything is because there's just not enough management talent to keep everything running along. Okay? Next week in production, we'll keep rolling along. Have a great weekend.